Hello my friends, alright, let's see if you got this right again. Predicting the test set results and displaying the vector of the predictions next to the vector of the real results, meaning the real purchase decisions. And I really want you to juggle with all your toolkits, whether it is the data preprocessing toolkits or your other machine learning models where you have indeed several tools inside, because indeed now the tool we would like to use is that, little piece of code that allows to display the two vectors of predicted results and real results. So what I expected you to do, to be the most efficient as you can, was to go to part 2 regression and then into the multiple linear regression folder and then open this multiple linear regression implementation, which indeed contains inside, so I already opened it, that tool allowing to display the two vectors of predicted results and real results. I'm talking, of course, about this tool, right? We implemented it many times. That's why I didn't want to do it again here in our logistic regression implementation. Plus, I really want to train you and incentivize you to be the most efficient as you can by juggling between your different models implementations. And so if you did this, if you had the reflex to grab that tool right here in multiple linear regression or many other models where we implemented that, well, congratulations, you did amazing. All right, so here we're going to take this. And of course, if you re-implemented it yourself, that's also amazing, especially if you manage to be more efficient than how we're about to be. All right, because what we only have to do here is to copy this little piece of code, that tool, and paste it in a new code cell here to predict the test set results, because indeed we have all the same names here for the vector of predictions, ypred, which will be the result of the predict method applied to test set and called, of course, from our not regressor object, but classifier object. There we go. So that's the first change you had to make. And then, well, since this time, our predicted purchase decisions and the real purchase decisions are either 0 or 1, well, we don't need to add anything here to, force the number of decimals after the comma to be only 2, right? Here we're only dealing with integers, so we can remove this. We don't need this. And then, final question here, did we have to change anything? Well, absolutely not. And that's what I mean by, grabbing a tool and applying it on your new model by only having to change one or two things. Here we only changed the name of the model type, from regressor to classifier. Okay, so let's check it out. Let's see if it works. Let's press play here. And indeed, we get the two vectors next to each other with first on the left, your vector of predictions, of the predicted purchase decisions for all the customers of course, the test set, right? This was applied to X-test here, so that's all the customers of the test set. And on the right, in the second column, you have the real purchased decisions. And so here, what's interesting to see is to compare the predicted purchase decisions to the real ones for all the customers in the test set. All right, so let's see. For the first customer of the test set, remember of age 30 and estimated salary $87,000. Well, the prediction is no, this customer didn't buy the new SUV, and the real result is indeed no. In reality, that customer didn't buy the new SUV. Good. Same for the second customer. That customer was predicted not to buy that new SUV, and indeed, it did not buy that new SUV. Third customer. This time, the third customer actually bought that new SUV, and our model predicted that indeed this new customer bought it. Well, it's funny, we actually have a lot of correct predictions. That's amazing, right? All this so far is correct. This is correct. And here we go. We have our first incorrect prediction. Here, our logistic regression model predicted that this particular customer didn't buy the SUV because we have a prediction of 0 here. But in reality, that customer bought that new amazing SUV. Okay, because the real result here is a 1. Then here it is correct, and here we go, another incorrect prediction, where our model predicted again that this customer didn't buy the SUV, whereas in reality, that customer bought the new SUV. All right, and you see, so that looks really, really good. Actually, we will get a very nice confusion matrix. I will explain very soon what it is, and mostly a very good accuracy, because the accuracy in the test set, of course, is simply the number of correct predictions divided by the total number of observations in the test set. And this is exactly what we're about to get in the test set. We will not only get the confusion matrix showing, so there you go, I'm about to explain what it is. The confusion matrix will show us exactly the number of correct predictions and the number of incorrect predictions for the two cases where the real result was 0 or 1. So basically we'll have a nice matrix showing how many mistakes and correct predictions our model made. And of course, inside the same new step or code cell, we will compute the accuracy and we will see what is the percentage of correct predictions our model made on the test set. So, should I ask you to try to do it on your own? Well, yes, why not? Because you just have to go to the API of scikit-learn and figure out how to make that confusion matrix and how to compute the accuracy. And I'll just give you a little hint. You will have to look into the metrics module from scikit-learn.